Okay, perfect. So this is how we are going to do this. Now we have altogether we have six different topics. Okay, so we'll be starting from problem solving and programming, and then we talk about data. Okay, this is the same thing which we discussed last week, and then we'll be talking about computers and communication and the internet, and also there's a part where we talk about the bigger picture. Okay, so this is all about talking about the computer's environmental impact and so on and so forth. Yeah, and hi, Binulaka. Good morning.
Morning, sir.
Good morning. How are you?
I'm fine, sir.
Good. Perfect. So I will send you the this thing as well. You have the soft copy with you, right?
Yes, sir.
Perfect. Okay. If you want, yeah. You have a hard copy as well. Perfect. Okay. Okay. All good. All good. So that's good. So yeah. So I'll share the link of this revision video I did. So there I went through all the structures and went through it. Okay. So quick question. So at school, uh, where are you guys at now? I'm still trying to remember where you guys were at. So nobody started this so far yet, right? I mean the curriculum. Okay, perfect. Okay, sounds good. Okay, so let's directly jump in. So you have this explanation about this book, and last week I talked about these important points. What are the main points we need to cover up, and how to go through this book, because this book is more than enough to like score an A plus into the exam, because it contains all the necessary information and all the points. Okay, so it's all straightforward. It's just about following the flow. Nice. Okay, so I'll jump directly into the first module. Okay, so yeah, by the way, yes, I'm controlling the full device with my phone, so that's why I'm keeping it on my hand. so so yeah, so starting off with unit 1. So where are we going forward with this thing? So when it comes to starting of a unit, so on the top of the page you guys can always see there are a certain set of items which is mentioned as the points which we will be covering up. Okay, so in this case we'll be talking about understanding algorithms, critical thinking, sorting and searching algorithms, plus well as we'll be talking about decomposition and abstraction. So during the last class I briefly explained what is decomposition and abstraction. So here we'll be jumping deep into it, and let's get our hands dirty with the concept. Okay, so problem solving. ප්‍රශ්න ප්‍රශ්නයකට උත්තරයක් දෙන එක. Right? Okay, so at the beginning of each unit we'll be discussing three primary points. Okay, so why do we need to learn this, and what is the objective, and what is the end result expecting. Okay, ඇයි මේක ඉගෙන ගන්නේ, මොකක්ද objective එක, අපි කොහොමද මේ ඉගෙන ගන්න එක use කරන්න කියන එක. Okay, so assessment objective 1, here you can see this would basically ask you to demonstrate knowledge and understanding of the key principles of computer science. Okay, so this is almost the same objectives in all units. Right? So objective 2 is to apply what you learned and understanding the key concepts and the principles of computer science. Okay, that's the second one. And the third one is analyze problems in computational terms to make reasoned judgments and to design programs, test, evaluate, and refine solutions. So what are these? So basically, once we are done with this module, you should have an idea about the exact concept of principles මේ මොකක්ද ඉගෙන ගන්න මේකේ knowledge එක වලට පුළුවන් වෙනවා demonstrate කරන්න. What you learn you should be able to demonstrate and show. Right? And then apply what you have learned into real world scenarios, then analyze. Okay, anyway, let's jump deep in and see what this is. Okay, so what is algorithms, and we are going to learn about what is and how to structure an algorithm. Okay, so guys, quick thing now, in my modules, in the way with the way I teach, I don't ask you guys to write huge paragraphs. Okay, IT කියන්නේ කොලේක පැනක ලියලා paragraph ලියලා ඉගෙන ගන්න පුළුවන් දෙයක් නෙවෙයි. Okay, so you have to actually practice this stuff, because IT is basically a practical subject similar to maths now you have to write it down, but IT it's all about practice and all about learning the keywords. Okay, so I will basically tell you to write down few specific keywords every now and then, so that we will be directly connecting whatever we write into the book. Okay, so at the end what you will have is something like a full set of short notes, where when you read it, it will connect with the final book. හරි ඊට පස්සේ ඒක පාඩම් කරා exam එකට ගියා done. Okay, but be careful, you cannot follow the same principle with other subjects. Chemistry, maths, ඒ වගේ subjects එක මේක යන්න බෑ, because they are much more theoretical subjects, and you have to write down it in simple English so that you can understand it. Okay, so I hope it's clear. Clear any idea? All good? Perfect. Okay, so first of all, learning objectives. මොකද්ද මොනකින් අපි ඉගෙන ගන්න හදන්නේ? Okay, so the learning objectives is primarily, hold on, does this okay. Now I try to zoom it in, but it's okay. So primarily we have to understand, we'll be understanding what is an algorithm is. මොකද්ද algorithm එක කියන්නේ, and why algorithms are being used, and what type of algorithms are being used, and we'll learn how to interpret කියන්නේ ඒක explain කරන්න algorithms as flowcharts, so and pseudocode, and write their descriptions in specific ways, as well as we'll learn how to use and describe the purpose of arithmetic operators. Okay, so this is where we can jump into calculations, and we'll talk about understanding how to code an algorithm in a high level language. So in this case we'll be using Python, and I will basically show you guys this with multiple different options as well. මොකද මේ code කරන්න options ගොඩක් තියෙනවා. We can go with Python, we can go with JavaScript, we can go with different types of languages, but then again let's stick to one thing and let's try to go forward with it. Okay, super. So an example of an algorithm. Hari. Okay, question. Algorithms. From your point of view, what is an algorithm? මොකද හිතන්නේ? මොකක්ද algorithm එක කියන්නේ? Come on. Ethan, what do you think?
Method of solving a problem?
Yes, up to a certain extent it's correct. Binloka, what do you think?
Most problem has more than one solution.
Okay, yes, that's also in a way it's correct, but okay, so in simple terms an algorithm is basically a set of rules, right? මොකක් හරි to execute some sort of a process, මොකක් හරි process එකක් උඩින් ඉඳන් පල්ලට යන්න, we do have this sequence of steps, right? So this sequence of steps are technically the algorithm. So example is, now if we take this one, this is just a simple route calculating system, right? Example, අපි හිතන්න මේ we are we are hailing a taxi using Uber or PickMe, right? So what it does is, first it will basically, sorry, let's say you are using Google Maps. Api koi hari yanakota we use Google Maps to find the location. So what does it do? It basically tells you a sequence of processes or steps you have to follow, right? It's technically telling you, okay, number one, it will basically go forward with an ambiguous, it is ambiguous in telling the driver exactly what to do, right? It says, okay, turn left or turn right or go straight at the next roundabout, right? And it is a sequence of steps. So these steps has to be specifically structured in order for you to achieve your final goal. So, and then it can be used again and again to provide the same result. Same as that. So that's the whole idea behind an algorithm. So it's a set of steps in a sequence which you will be using to achieve a task or achieve some sort of a output. And this will be provided in a step-by-step manner so that you can reuse it and get the same result. Okay, got the idea? algorithm එකක් කියන්නේ මොකක්
Yes, sir.
හරි list එකක්, items list එකක් අපිට ඒක set up කරලා තියෙනවා, so you can follow the same thing. Okay, so similar to this idea, so now in a simple answer you can see here under the subject vocabulary, you can see the simple answer is algorithm is a practice method for solving simple problems. Okay, small answer එකක් આવොත්, small question එකක් આવොත් with a small answer, you can obviously tell this one. Okay, and what is a sequence? A sequence is an ordered set of instructions. Instruction set එකක් polymer තියෙන instructions ටික. හරි. Okay, so if we jump to the next part, so now when it comes to algorithms, now okay, so now there are two different things. Okay, so now when it comes to understanding algorithms, there are points where but note that the make ඉස්සල්ලා ඒක lazy. Can you guys write this part down? So just write what is an algorithm. So go through this pattern. So since this is the unit 1, write as unit 1 and understanding algorithms, and then you can write what is an algorithm. So hold on. Yeah, perfect. So an algorithm is a precise method for solving a problem. Also, if you can, please write down the particular page number as well. Now, this is under unit 1 and unit 1 under the understanding algorithms. So that we do have, when we are going through this, you will have a short note of everything to understand and see what is exactly going on. Okay, so right, okay, can I jump to the next one? All good?
Wait a minute, sir.
Sure.
So, what's the sentence you gave, sir?
Yeah, so the sentence is an algorithm is a precise method for solving a problem. You can see it here, which my cursor is at this location. A precise method for solving a problem. We do have some questions at the end of the unit as well, no? So I will obviously give that as homework so that you can start working on that. All good? Binlaka, shall we go down?
Okay, sir.
Perfect. Okay. So nice. So understanding the algorithms. Now, when it comes to the general vocabulary, again we have this particular point which we known as outcome. Okay. So whatever the processing which happens, we always need to find out what is the expected outcome, right? So an outcome, the idea or the meaning behind outcome is the final result of an action. So when an action happens, an outcome is what is going to be the final result. Okay, and let's see. So when it comes to deciding an algorithm, whether it's good or bad, whether it's successful or not, okay, there has to be a few points. Okay, so number one is the accuracy. Okay, now we'll think about this in a way. Like හිතන්නකෝ අපි මේ let's say we are traveling from Colombo to Kandy. Okay, so in this path, when we are going to Colombo to Kandy, let's say when we put it on Google Maps, if it shows us the route which will take us, like let's say 6 hours, so let's say 10 hours to go to Kandy. පයින් ගියත් ඊට කලින් යන්න පුළුවන් වගේ route එකක් පෙන්නනවා. Then will that be accurate, and will your expected output, will it support your expected output? Technically no, right? Because the reason you would be using Google Maps or some sort of a navigation tool is because you want the tool to give you the best available route, right? ඉක්මනටම යන්න පුළුවන් path එක හොයන එකනේ goal එක වෙන්නේ. So that means accuracy must be precise, right? So you need to have precise accuracy so that it must lead to the expected outcome, which is going to be the fastest route to Kandy. Okay, got the idea? So that is part one. That is the first thing. Yeah? And the second thing is it should be consistent. Okay, so
So you have to write it.
no, Liam, first we'll go through this. Okay, so first I'll explain, then we'll write it. So you got the first point, no? Accuracy is clear, no? So it should
Yes,
be
sir.
accurate. Then the second point is consistency. So now think about this in a way. Then okay, so we use Google Maps once, and let's say okay, we got the best route to go to Kandy from Colombo, and okay, so we go to Kandy, and next day or next time when you use it, if it kind of gives you a wrong route, then again that algorithm is failed, right? So your algorithm, your system should always provide the same result each time when it is executed. Right? So example is okay, so Google Maps product complex because sometimes now, if you guys know, Google Maps uses traffic data now. So depending on the traffic congestion, they basically reroute you. So sometimes you might get one route, the next time you might get a different route. So, but in a way, in that case, still this outcome is going to be the same. Hari? See, the outcome would be the same. Hitanna, now, so we want to find the fastest route to Kandy, right? So your goal is to go as soon as possible to Kandy, but then again, depending on the road conditions, let's say if the road is closed at one point, then obviously you should be redirected to a different path. So that is what the outcome comes. That is where the outcome comes in, but the thing is, consistency should be always the same. So the result should be always the same. අපි හිතමු මේ කැන්ඩි රවුට් එක දැම්මම ගාල්ල පෙන්නවා කියලා. Then that's a big failure in the algorithm, right? Okay. So then the most point and the third most point is efficiency. So efficiency is mainly focused on it must solve the problem in the shortest possible time using the fewest resources as per let's say few computer resources as much as possible. So again, if we look at the Google Maps example, always the efficiency has to be there, right? So efficiency means the map should be efficient, shortest path taking වැඩේ පෙන්නන්නත් ඕනේ, plus it should run as fast as possible, right? So it should give you an efficient output so that it will be basically replacing one of your points. Hari, before we write this down, let me explain you one more thing. Now, when it comes to the software industry, we have this. So, algorithms okkome hadanne. There is because of one reason. So, it's all about a pain point, right? So, what is a pain point? A pain point is something which you will have in your system, or a problem you have. Okay. Tell me a problem which got resolved by computers. මොකක් කරේ තියෙන issue එක computers නිසා හැදිච්ච එක. Not actually hacking. Nah, anyway, think of a real world scenario where by getting new technologies that was advanced and it made our lives much easier. AI, yes, AI is there, but okay, think of a problem we had. Hari, have you guys went to watch a movie at City Center or Havelock?
No, sir.
No, okay, but you have went to movie theaters, no?
I have to watch the movie that releasing at Dragons, How to Train Your Dragon.
How to Train Your Dragon. Yes, yeah.
It is also IMAX.
Yes, yeah. Please do go to IMAX for that. Okay, now when you're going to watch the movie, where will you buy the ticket from?
From the cashier.
Or
Online.
Exactly. So so now that means you can either book the ticket online and you can select the exact seat you want, and then you can make sure that the seat is available. But if you go back about 20 years ago, when we wanted to go and watch a movie, there were times we actually go to the movie theater early, like about half an hour to 1 hour early, to get the best seat. Otherwise, you won't get it. අපි ගිහිල්ලා ටක් ගාලා ටිකට්ස් ටික බුක් කරලා වෙන කොහේ හරි යනවා. We have lunch and all, and then we come back to watch the movie. Otherwise, we won't get the best seats. So now that was actually a problem, right? That was a pain point we had. So හතරමාර ෆිල්ම් එක බලන්න we go around 2 o'clock. But now with the technology, that pain point is not there anymore. So if I want to go to the fourth show, I just book. You take my phone out. I just book the show, and I just go there. Right? So that is what the whole idea. Sorry, that is the whole process we try to solve using algorithms. So example is like if you apply this algorithm concept into the tickets, it has to be accurate. So the ticket must be booked. Ne? සල්ලි ගෙවුවට පස්සේ ටිකට් එක දෙන්න බෑ කියන්න බෑනේ. That has to be accurate. Plus, it should be consistent. So every time when you make a booking, it should make sure that the booking is done, right? And then efficiency. So when you try to book something, you should be able to book it as soon as possible, as well as it should be able to support multiple users, and the system should work really fast. Okay, නැත්තම් දැන් හිතන්න මේ if you go to book a ticket online, if you have to wait for like couple of minutes to book it, then that is also going to be a problem, no? Right?
Yes.
Okay, so that's the whole concept behind this particular flow. Okay, now please do write this down. So there are 3 points. So when it comes to an algorithm, we have 3 points. Okay, so the point number 1 is accuracy, number 2 is consistency, and number 3 is efficiency. Okay, so accuracy, I'll let you write it down. Yes, please go on. So there are 3 points to consider when deciding an algorithm is successful or not. Okay, so for that, it's number 1 is accuracy. So it must lead to an expected outcome. Okay, that part is enough. So just write this part. It must lead to an expected outcome. So whatever the process you are following, it must lead to an expected outcome. And then consistency. The consistency, it must produce the same result each time it is run. Writing this line would be more than enough. Huh? And also, guys, highlight these words: accuracy, and outcome, and consistency, and efficiency. Ethan, you're also writing it down, right? So highlight the words accuracy, outcome, consistency, and efficiency. So these are the keywords. Okay. So efficiency means it must solve the problem in the shortest possible time using as few computer resources as possible. Only this part would be more than enough. Okay, sorry, I tried to highlight it and it went a bit off. Anyway, okay. All good? Shall we?
Wait a minute, sir.
Yeah, sure. Take your time. No problem.
So what were the points in right?
Yes. So point 1 is accuracy, and point 2 is consistency. Okay, 1 second. Yeah, and the point 3 is efficiency. So I'll read it again. So for accuracy, for the first point, accuracy, it must lead to the expected outcome. Okay, so the accuracy means whatever the execution you are going to do, it must lead to the expected outcome. Then consistency means it must produce the same result each time it is run. So it should always create the same result every time. And then we have efficiency. So efficiency means it must solve the problem in the shortest possible run using as few computer resources as possible.
Done?
Okay, yeah, we'll wait for. We'll wait for Ethan as well. Ethan, just let us know when you're done. Okay, shall we jump into the next one to talk about the relationship?
Okay, sir.
Ethan, you're also okay, right? So,
Okay, sir.
perfect. Anyway, this video will be uploaded after the class. You'll have to give me a little bit of time because usually these videos are like huge. It's about 4 to 5 GB gigabytes. So it takes a bit of time to upload. But once it's uploaded, the link will be available through your LMS so that you can refer to this anytime. Okay. So, perfect. So then we talk about the relationship between algorithms and programs. Okay. Now, this is what we will be continuing to learn during the next steps. Okay. So algorithms are basically programs which are like let's say when we call it an algorithm or a program, it basically they are closely related to each other, right? But they are not the same. Okay. Now, we have this. Okay, I think you guys might have seen the on movies where there's this hacker guy who will be like typing something on a keyboard and he'll say, "I'm building a new algorithm so that." This XYZ thing will happen, right? So they type something on a keyboard and they say, I'm creating a new algorithm, right? So
Yes, sir.
so usually you used to see those things, but the thing is that's like something totally different, right? So algorithms are like detailed designs for a solution, like as we talked about this flow. So algorithms is kind of like a design, and a program is actually something which will be implementing that design. Okay. So an algorithm is the design, and a program is something which will basically follow that design and will implement it. Alright. So let's say if Binlaka is creating a algorithm to okay, algorithm to a hack a business. Okay. So first of all, in order for you to hack a business, you have to learn how they work, what they do, what type of applications they have, what are their networks, and you have to come up with a flow, like a certain set of steps, right? So that's the algorithm you would be building. And after that, you can actually give that to Ethan. So Ethan might not know what is you're going to do, what evil intentions you have with that business, but and he will just develop you the program. So you build the algorithm, he develops the program, and you deploy the algorithm, you deploy the program, and you hack the business, and Ethan goes to jail. that's that's normally what happens when it comes to these type of nasty applications. Okay, so I hope you guys got the difference between these two. So the algorithm is the
Yes,
set
sir.
of steps, program is the program. So Now, this unit is all about algorithms, but we will look how these algorithms are implemented using a high level language, which is going to be talked in the second unit. Okay, so second unit we jump into programming. We'll dive deep into Python, and then there will be some examples and stuff. And also I will you guys will find another video in my channel on how to set up Python. So it's not yet uploaded, it will be there in by the time you guys again see this video, you might find it there. So I am creating a small video on how to use Python on Google Colab. So you don't have to install it on your machine, you can just run Python code on Google Colab is itself, which is the online version of it, and you can check and see how it works. So perfect point. Can we just quickly write this down? So the relationship of programs. So if you can, can you write this particular paragraph down? So algorithms and programs are closely related, but they are not the same. Okay, an algorithm is a detailed design for a solution. A program is what that design is implemented.
So do we think like algorithms and programs are closely related?
I like if you can write it, because the thing is, in your exam I have seen this question where it asks what's the difference between an algorithm and a program. We had couple of questions. So if you get the question, this is the exact answer you have to write. But if you write this part is also enough. And algorithm is a detailed design for a solution. A program is when that design is implemented. Write it in your own words. All good?
So up to where we have right?
Yeah, so just this part. This would be enough. An algorithm is a detailed design for a solution, and a program is when that design is implemented. This small paragraph would be more than enough. So the topic should be the relationship between an algorithm and a program.
Sir,
Yes.
I watched the trailer of the Doomsday.
Doomsday.
Marvel Doomsday.
Was there a new trailer?
Yes.
When is it? When was it?
2006, 26. They are releasing the movie.
Oh, the trailer. Yo. No, I just saw that there's a new trailer. See, literally, I got goosebumps. Okay, need to check this out. Chris Evans is also there, no?
Yes.
Chris Evans, Captain America.
Yes, yes.
And Tom Holland is also there, so it's kind of like a
Yes.
okay.
It is kind of like an endgame. The Doom is the Iron Man.
I know, yeah, that's the thing. So, okay, yeah, you lot of okay, a certain set of Oscar Isaac is also there. Okay, that's interesting. Did you have you watched Moon Knight?
Yes, of course.
Okay, so that Moon Knight character is also there, Oscar Isaac.
Yes.
So, okay, I'm not sure whether they are going to bring Moon Knight into Doom because it's like totally two
Yes.
different things. Okay,
The
need to
Moon
watch.
Knight is also.
Moon Knight is not
I
there, no? Is Moon Knight is there in the Doom movie? Okay,
no.
I don't think so. Need to check that because Moon Knight is okay. That's a whole different universe. Moon Knight's universe.
Yes.
Okay.
And you watched the last Venom the Last Dance movie?
Yeah, I actually went to the cinema and watched it, but it was not that good, right? It was
Yes,
just
the
a movie to
last
finish
scene
it.
isn't good.
Yeah, they were just I felt that it's just a movie that they did for the sake of doing it.
Yes.
Like
But
apart.
the Noel isn't the villain.
Yeah, that's the thing. So that's a weird thing. But then again, I'm not sure why they stopped it. So but then
They are
again,
playing the fourth one also.
yeah, that's the thing. එතකොට that means they might have to get it into another universe. You never know. Because
I think Venom will be combined with the Tom Holland. Spider-Man?
Spider-Man's universe, but there's a thing, huh? When it comes to the official comics, if you have read the comics, in the official comics,
The
Venom
bad
is
guy.
Venom is a bad guy, but what's his name? What's Peter Parker's friend's name? Ozzy Osbourne, right?
Osborn.
Osbourne's son.
Eddie
Huh?
Osborn. Eddie Osborn.
Eddie or Harry Osborn, right? Harry,
Yes.
yeah. So in the comics and in the Spider-Man game, Harry is the villain. Harry is basically Venom.
Yes.
So if they are getting in Venom into the movie series, then they should completely revamp the whole thing. They'll have to come up with a new Spider-Man and a new Harry and a different storyline. But hopefully they'll do something. And
The Harry is the green column in the
Harry
movie.
in the
Green column.
yeah in what in the first Spider-Man series, Harry is the Green Goblin. It's a big mix up. Anyway, let's
But
see.
Holland is not having friends at all.
Sorry.
But Tom Holland is not having friends at all.
Yeah, exactly. That's the thing. So in the Tom Holland's universe, Tom Holland doesn't have a girlfriend. He doesn't have any friends. Now no one is there. So now it's kind of partially gone. Now you can't reload the universe unless you take it to a different universe. So that's the thing now. Okay, so okay, I just quickly explain this part. So when Marvel Comics started back in 1940s, the reason Marvel this Stanley wrote that comics was during the World War. They needed to have some sort of a action figure to promote the US Army and show them that the US Army is capable of fighting with the Nazis, with the Hitler's army, German army. So that's why they came up with Captain America. So that's why his shield is the American sigil, and Captain America original stories. Captain America was fighting with the Nazis, this German army. Then it came Iron Man. Iron Man was also part of the army, and so on and so forth. So these guys came in, and by 1980s, this whole characters list was too much, and they were not able to create new stories. කතන්දර ලියනවා කියලා තෝක ලිමිට් එකක් තියෙනවානේ. So what they did was they introduced, they said that this is a specific earth and there are multiple earths. So in by 90, I think this was by late 1960s. Even this was like when our parents were small, when my parents were small. So by that time they came up with the multiverse theory. So then they split it into different parts. So you had Earth 1, you had Earth 100, and each Earths had different timelines. Now Spider-Man also.
That franchise may destroy the timeline in the Spider-Man movie.
He destroyed it, but in the Doctor Strange movie he got it back again.
Yes, and the Venom has come to the Tom Holland's universe.
Venom came to the Tom Holland's universe and went back. Venom 2 එකේ අන්තිමට he was actually transported into the Tom Holland's universe na. මතකද?
Yes.
Venom එකේ අන්තිම
Yes.
කෑල්ල. And then again when the new Venom started, he was taken back to his own universe.
Yes.
So now so they actually, I think they did that on purpose just to show that Venom is
angry with Tom Holland.
Yeah, and that to show the audience that Venom is coming from a different universe.
Yes.
That's the thing. Okay, let me watch that trailer. Mayaka balla message danna. I didn't I was not able to browse any YouTube recently. I think that was released like today or yesterday, right? Trailer? Adada dakke trailer එක. Should be okay. I didn't see the trailer anyway. Okay, anyway, so let's jump into this one and
I think it would be January 1, first or the
Omin, when is the release date?
releasing date.
2026.
Yes.
May 1st,
Releasing date is
2026. Ambo.
I think you tell me about the trailer releasing.
No. Ayyo. Okay. Now, 2020.
We have to wait 1 year and 2 months.
Yeah, almost 1 year and 2 months to watch the movie. Okay. But before that, I think there's a lot of other movies coming out, right? So there's there's a Captain America movie coming out and so on and so forth. So there will be some movies for sure. Okay. All good. So let's jump into this part. So far, I hope you guys have the idea of an algorithm. Now let's jump into this one. So now last week I explained this in a little bit of a different way, where I explained you on how to make a cup of coffee. Okay, so this is the same flow. So let me show you how to understand an algorithm. Just a quick overview on this. Hold on. I just need to show you how algorithms are really important. How to make a okay, 1 second. Okay. So no, hold on, I need to find the high quality video. Yes. Okay, so now when we are talking about algorithms, this is the most important thing. Okay, so when you're making something, the algorithm is really important. Okay, and it should basically tell the exact steps on how it works. Otherwise, let's watch this video and see how you can make a simple mistake in an algorithm and make a big mess out of it. Okay, so let's watch this.
Making any sense. Sorry, ruined it on purpose. He knows how to make one.
What's up, the internet? You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you think you can write down something?
Okay, so this father is basically asking his son and daughter to write down the flow of how to make a peanut butter and jelly sandwich. Okay, now just think. Okay, you guys, both of you know how to make a sandwich. No? You just take some butter, you take a piece of
Yes,
bread and you apply it, right? But now think, when you want to tell someone else how to make a sandwich, now you two know how to do that, yes, but when you want to tell someone else how to how to make this, see how hard it is. Okay,
Instructions and teach me how to make a peanut butter and jelly sandwich?
you guys can hear the sound, right? Yes,
Sir.
perfect. Yeah, perfect. Okay.
Then do it.
I knew we were gonna do this. I heard Dad talking to Mom.
Choke yourself on my hand. Sometimes they do what you tell them.
So the requirement is to write down the exact algorithm, the exact flow on how to make a peanut butter and jelly sandwich. Okay. See the issues they get into.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter and jelly sandwich.
You see the problem. So now making a sandwich is easy, but see, when you're writing algorithms, this is why computer algorithms are very complex, right? So you have to be very precise. Okay, let's see the next one.
Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out of the...
That means like a lot.
A bit means a lot?
In my world.
Spread yours.
See the definitions now. When we apply a value to a variable, now she said bit is a lot. You can't say like that. If it is 1, it should be 1. Nah? Okay, so let's go through it again.
Scoop of peanut butter onto 1 of your pieces of bread with the knife. Alright? There we go.
You're doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
No.
Done. Closer. Get 2 pieces of bread. Get some peanut butter. Take the peanut butter knife. Open the peanut butter. Put the knife in the PB. Get some jelly. Open the jelly.
No.
Squirt the jelly onto the bread. Take the butter knife with the peanut butter on it. Wipe it all over the piece of bread that's blank. Take the butter knife, rub the jelly all over the piece of bread.
Oh, he's doing better. Oh.
That's all over. Put the two pieces on top of each other.
This isn't how I meant.
Take two pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto one of your pieces of bread with the knife.
No.
Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your two pieces of bread, peanut butter and jelly sides together. Done. Get two pieces of bread. Get some peanut butter. Get some jelly in the peanut butter. Get a butter knife. Put the butter knife in the peanut butter. Take the butter knife out of the peanut butter.
Look at his face.
You did it wrong. No.
Take one piece of bread and take the butter knife that has the peanut butter on it, spread it all over the top of the piece of bread.
Dad,
That's the top.
I mean the sides.
Squirt some on another piece of bread. Take the butter knife, rub it all over the top of the piece of bread.
I quit. You're not even making any sense. Sorry, you ruined it on purpose. He knows how to make one. I know, Evan. It's the joke. It's the game that was like. Oh.
Do you know how to eat a piece of bread? You want to take your sandwich with you?
He finishes it off in ultimately.
Looks like a yummy sandwich.
Okay, so now I just want to show you guys how hard it is to come up with a exact algorithm. Okay, so similar to that point, now when you're building software, that's why you have to be very precise. Okay, so an algorithm has to be precise, otherwise what happens to your code? What's the crash? But we do call them one more different term. We say you get bugs. Right? Your code becomes buggy because you tend to get errors. Now in that video you saw, like, when the instructions are not correct, like when you say apply peanut butter on top of the bread, top in the sense like if you take a piece of bread, top means on the crust, no? So it's correct. So the instruction is correct, but your expected outcome or the output, the algorithm's output. So this is the point we discussed here, right? So the algorithm must have its consistency, and the algorithm must be accurate, right? So without the accuracy, it won't work out. So that algorithm must be accurate and it should be consistent in that same example. Okay, so we have this example, algorithm of making a cup of coffee. So fill the kettle with water, turn on the kettle, pour coffee in cup, wait for the water to boil, pour the water into the cup, add milk and sugar and stir. Okay, simple as that. So now tell me an answer for this one. So let's create a algorithm for getting to school. Okay, now you should start it with leaving home and ending with arriving at school. For example, the algorithm could start with walk to the bus stop. Okay, now put the topic, write this down, put the topic as going to school, and shall we write it down? You guys tell me the steps. You have to write down your own path when you went to school. how you did it. So what would be the first stop? කොහෙන්ද පටන් ගන්න? So the first, now here it would be walk to the bus stop, right? Here the point would be walk to bus stop. But okay, Binulaga, how what would be your first step? Oh, Ethan, either one of you can go.
Get on the bus which stopped in front of you.
Okay, but getting on the bus or no? Think about the peanut butter sandwich thing. So, getting on the bus, are you immediately getting like apparated inside the bus? No, no. So, where's the bus is? Bus is at the bus stop. So, first we have to go to the bus stop. Right? Got the point? Got the point? Okay. So, you normally go to school by bus, is it? Went to school by bus. Perfect. Okay. So, now that means where is the bus stop? Is it near your home?
Yes, sir.
Okay. So then for you, then you can actually start by writing as walk to the bus stop, right? That would be the first. Okay. Binulaga, what is your flow? Where would you start?
Walk to
When you went to school, how did you normally go?
my father.
Father dropped you off.
School, no.
Huh?
I'm not going to school.
You don't know. I mean, when you went to school at some point
With my father.
with your father. Okay. So what's the flow? So you get ready and you went in your car.
I went to my garage and
Get into the car.
get into the car
Perfect.
and
Okay.
went to the school.
Nice. Okay. So then your first one would be what? What would be the first action?
Go to the garage and
Okay. I'll
told my
no. Abhi මෙහෙම කරමු. I'll make it much more. I'll make the question different. Think that both of you are trying to train a robot. Okay. So you're trying to send a robot to school on behalf of you. ඔයාවගේම robot එකක් ඉන්නවා. Now you want to send that robot to school and stay home and sleep. Okay. Now you're programming the robot to follow a specific set of actions where it should mimic exactly the things which you do. Got it? Then what would you tell the robot first? What would be the first action?
wake up at 7:30 p.m. and go
Nice.
to the bathroom and brush your teeth
Okay.
and come and get the towel and get a shower
Okay.
and go to the
Dress up.
dress up and
Eat something.
eat some sandwich
Okay.
and go to the bus station and get a bus.
Okay.
Get onto the bus
Got it.
and go to the school.
Okay.
Talk with friends.
Okay. Yeah. Go to the
say
school.
hi.
That's enough. Yeah. We can finish up that point. Okay. Can you write this down? What you just said. Just write it in simple points. Okay. So, Ethan, what would be your points? So, think you have created a copy of yourself, and then how would you give the conditions, the flows?
wake up at 6 o'clock.
Okay, that's an action, right? So yeah, go on,
Ready
yes.
for the, yeah, I can get ready for the breakfast,
Perfect.
eat sandwich and drink a cup of milk
Okay, that's good.
and go to the
Yeah,
washroom and brush your teeth and wash your face and take a towel and go to take a bath
yeah,
and come to the dressing room and dress the uniform
yeah.
and getting ready to the bus to come.
Okay, so you go to the bus stop and then you jump on a bus. Right, nice, perfect. So now you guys got a base idea. So just can you write it down and write it down in a way where you can actually simplify it. You don't need to write down very minute details. I mean, what you. So let's say you don't have to say you drink a cup of milk. You can just say have breakfast. Likewise, and can you write down the points? I'll give you a few minutes. The reason I'm asking you to write it down is then we can rewrite it according to the flow charts.
So do we need to write it down?
Yeah, write down the basic points you just said. So waking up, washing, and then I'll teach you how to write this in flowcharts because the next topic is to jump into flowcharts.
Done?
Hi, okay, perfect. Okay, shall I jump to the flowcharts? Okay, nice. Okay, now we learn about now we know how to structure something, right? So now we know the basic of an algorithm. Let's understand. So in this example, what we are going to see is the same algorithm which we saw on the top, which is the algorithm of making a cup of coffee. Okay, so we fill the kettle, we turn on the kettle, we place coffee in the cup, wait for the water to boil, pour the water into the cup, and add milk and sugar, and then we stir. Okay, so this particular same flow, now this is how we write it down. Now, let's say, in order for us to make it easy for us to understand, what we do is we have a specific method of writing these things. Okay, I think you guys might have learned about flowcharts in the previous years.
Yes, sir.
Yeah, I think that is there in grade 7 as well, right? 7 and 8. Yeah. Anyway, okay, so let's go from the beginning. So flowcharts is basically a method of showing algorithms as diagrams. Okay, so flowcharts can be used to show an algorithm as a diagram. So they provide a more visual display so that people can understand it easily. Okay, now it's like this. So in that previous video you guys saw, so that father was actually asking his children to actually write a simple algorithm, but they fail to specifically, they know how to do that, but they fail to specifically say, because there was no structure. Right, there was no specific structure. Now these flowcharts will basically allow a user, anyone, to come up with a, to draw or to come up with a structure which can be understand, or which is clearly, which can be clearly understood by someone else. Okay, now there are few symbols you have to be mindful of. Okay, so primary symbol is this one. So this is, so these two, so usually sometimes in some diagrams you can see this as a circle, or like a bit of a rounded square.
Yes, yes.
And
Yes, sir.
yeah, and sometimes in some diagrams you highlight it. Okay, so just keep this in mind. So this is the start. So whenever you start a process, you use the start symbol, and then you use the process block. So the process block is the one which will be used to define some sort of an action. Okay, process එකක් කියන්නේ action එකක්. දැන් අපි උදේ නැගිටිනවා නම් yes, that is going to be an action. Okay, and now we jump into the interesting part. This is the decision symbol. Okay, now here what it says is, this indicates if a decision is to be made. So what is a decision? Once you wake up in the morning, your parents give you two options, either to drink milk or to drink a cup of Milo. Okay, now you have a problem. මොකද කියන්නේ කිරි බොනවාද Milo බොනවාද, කිරි බොනවාද Milo බොනවාද. So then
Cup of coffee.
yeah, coffee එන්නත් පුළුවන්. Okay, so then you might have a decision to make. Okay, so let's say if there's a specific outcome, අපි කිරි Milo දෙකම අයින් කරමු. අපි ගමු මේ let's say if we take a okay, when we are going to school, you might get the option of getting into two different buses. Bus routes මං කියන්නේ bus දෙකක් යන්න පුළුවන්. Now while I was going to school back in the day, I went to Wesley College. So when I was going to Wesley, I had two options. I had the option of getting into 176 170 bus එක කරගම්පිටිය හෙට්ටිය බස්, or I had the option of getting into 178 කොහුවල and Mattakkure. I can't remember the location. So those two buses traveled in two different routes. Okay, so depending on the time, we select these buses. So if we go early, then we go on 176, because that is, sorry, if we go late, we go on 176 because the 176 is faster. If you go early, we take 178. So now this is a decision block. Now if I apply this to my school days, then I would be taking the decision, check the time. If the time is let's say past 7:20, then get on 176. If the time is 7 or less than, if the time is 7, then get on 178. You got the idea. There, likewise, you have different ways of making the decisions.
Yes, sir.
And then you have the input and the output. So this is the same part where we will define what type of an input or an output which is going to be sent into the system and which we are going to get out of the system, right? So here this will act as two different um, act in two different ways, as well as
Input and output.
yeah, that's it. So just as two actions, and then we have the logical flow, which is basically the arrows. Huh? So don't, this is not complex. Huh? It's like very straightforward and easy. Only thing is, we won't be going very in depth into flowcharts, but we do write flowcharts, which is like massive sometimes, because in the industry sometimes when we build an application, before we go with the final application flow, we do build flowcharts, because couple of reasons. It's easy to explain it to a customer. මොකද customer කෙනෙකුට when you show the flowchart and explain him this is the flow which we are following, he understands it. So otherwise, if you just tell him in paper, this is what you are going to get at the end of the day, it's not going to work.
He will be confused.
He will be confused, exactly, because same as that peanut butter sandwich example, the customer is someone who has no clue about the solution. He has the problem. So he that father wanted to have a peanut butter sandwich, so that's the problem, that's the pain point, and he wanted a solution. Okay, so here if we apply the same flow into the flow chart, which is the making of a cup of coffee. So here we start and we fill the kettle with water, and we turn on the kettle, right? And then place coffee in the cup, wait for the kettle to boil, pour the water into the cup, add milk and sugar, stir, and you get the exit. Okay, so in this flow we did not had any conditions, right? Because it's just a simple flow starting from the beginning, which goes until the end, and it didn't had any conditional points as well, right? So no conditions were there. It was just a straightforward flow view, right? Okay, so now shall we write the same thing, the same journey which you guys just wrote down in the same pattern? So right next to what you wrote down, can we write this? So we start, okay? So the start would be the first point where you start, and then let's.
Up at 7:30 a.m.
Where did you start your journey?
Get up at 7:30.
Get up. Okay. So then you could start as wake up, okay? Wake up, and then can we write it down? Just make it simple. Huh? You don't have to write a big story in it. And these activities, always Binloga, keep this in mind. Also, Ethan, when it comes to explaining a point, make it simple. ලොකු හැලක් කියන්න එපා. මෙහෙම වුණා කියන්න ඕනේ නැහැ. If you just can say to the point saying, okay, this is what you need to do. So example is now like, hurry, okay, think of a robot, okay, then robot එකක්, the robot, still if it is a robot, that robot should have the memory to go and open a door, no? So you don't have to say walk to the car, place your hand on the handle, lift the handle, open the door and get in and close, right? You don't have to say like that. You just need to say walk to the car, or go to the garage, get into the car. You got the idea? It should be simple and straightforward. Huh?
Yes, sir.
Okay. Can you write it down? ලියලා මට පෙන්නනවද කොහොමද කියලා? Come on.
So,
Yes.
walk to the bus stop at 6:45 a.m. That could be a decision, right?
Yeah, you can that yes. Sorry, that could be a it's like this. So that can be a decision, but the problem is what would be the outcome. So if it is a decision, there has to be two different outcomes. So there has to be a yes and a no. So let's say let's think about this in a different way. Okay, let's say you have a bus which leaves at 6:45. So then you can say arrive at the bus stop at 6:45. Yes or no? If it is yes, you go to school on time. If it is no, you will get late. තේරුණාද ඒක? එහෙම වුණොත් හරි. එහෙම වුණොත් පුළුවන්. Otherwise it's not, you don't need a conditional factor in this case. Sorry. Can you write it down? හරි නේද? තේරුණාද idea එක?
Can you explain, sir?
Yeah, so now the condition point, now let's think about this in a different way. So now let's say if you go to the bus stand, so let me start from the beginning. So going to the bus stand at 6:45 would be an action. Ne? Ek action ne. But there's a problem. Now if you want to add this into a conditional factor, then how it will work out is, you can say, you can add a condition, you can add this part, add the condition, the decision view here, and then you can say arrive at the bus stand before 6:30, let's say. So before 6:30, and you would have two actions, either yes or no. I make a condition එකක් මේ condition එකේ true එකක් තියෙනවා, true එකක් වෙන්නත් පුළුවන්, මේක false වෙන්නත් පුළුවන්. Got the idea? එක්ක මේක හරි වෙන්නත් පුළුවන්, මේක වැරදි වෙන්නත් පුළුවන්. It can be true or false. So if that's the case, then මෙතන එතකොට then you will have to tell this as a condition. So you say you arrive at the bus stand at 6:30. So if it is yes, true, you go to school on time. If it is no, you go to school late. And if you go to school late, ඔන්න වෙනම තව flow එකක් යනවා. උදේට අල්ල ගන්නවා, ප්‍රිෆෙස්ලා අල්ල ගන්නවා, ගුටි ගන්නවා, දන ගාගෙන ඉන්නවා. You'll have to go through that entire flow. You got the idea? Okay, so I think for the moment in your, what you have written down, it should look something like this. It will be a set of processes. Done? Tavalira?
Yes, sir.
Okay. Got the idea, right? So just make sure.
We need to add that block, right?
Yes, so you start from this block and then you go through the flow like this. Okay, so you go through the flow like this, and then at the end you end it. Ask me if you have any questions.
We have write the exact model shape.
Shape in the sense as long as it looks like this, then it's okay. For the exam also, make sure that you won't mix these two up. Either you can write this as a circle, that is also okay, but also keep in mind in your exam you get this exam guide booklet, no? So in that booklet you will get all these symbols. The booklet will actually show you all the available symbols when it comes to
Okay,
the,
sir.
yeah, so that has it in it actually.
Done?
Hi, okay, can you show it to me? Turn off your blur. Book එක, otherwise the book is getting blurred. Click on the small arrow next to the video icon and nice. Perfect. Okay, wake up and then. Okay, nice. Okay, so there is no such thing as a specific order, but when you're writing it in the exam, just make sure that you write it in a nice kind of like a waterfall method. So here you have it because
Okay, sir.
it's written in a flow because of the space restrictions, but ideally if it can be written from top to bottom, that would be the best. Okay, perfect. Ethan, are you okay? How is it?
Yes, sir, but still right.
Yeah, okay, go on. I'll give you a few minutes. Binulaka, have you seen behind the scenes footage of these Marvel movies?
Yes, sir.
Yeah, so have you seen what is a storyboard is?
Yes, sir.
And so the storyboard is same thing as a flow chart. So storyboards, what they do is they basically take each and every scene of the movie or the cartoon and they create huge boards and they draw small like drafts and they paste it. And then when you look at the storyboard, you can see the entire story, what's going to happen. That's how they imagine. So the storyboards, those are the points which, as they say, which takes the most time because you get to get people in and they sit together and they create, they start building the story. So just think you're like you stand in front of a big board and you try to think of the story, how it works, all these powers and the way they hit each other and all these things. Quite interesting, eh? And they do the same thing for games also. So now this now if you take something like an Unreal, you know what is the Unreal Engine, right? The gaming engine. So if we take an engine like that, then that also when it comes to the gaming parameters, it's again the same concept. It's again a flow chart where you have the conditional operators as well as the inputs and outputs, and based on that you create the story. So this is the foundation of everything technically. So let's say if you are trying to build a game, still then again you will need to learn how to create the flow charts in order to make sure the game is properly structured. Okay. Ethan, all good?
Wait, sir.
Hurry. Go on, go on, go on. Take your time. Take your time. No problem. We are not in a hurry. Yeah? We can go. We'll take slow and we'll go through it. Halo.
Did you play this game?
Oh, I used to play Halo a lot. We played Halo back in 2000 and I don't know when the Halo came out.
2063?
I don't know when was the first Halo released.
2019.
Uh, I played the first I played the first Halo game which was released in 2001. That was actually not by Microsoft. ඔය Halo එක ආවේ Bungie Studios කියලා company එක. So that was released for Windows 98 and I played it in Windows XP. Interesting game, Master Chief.
Aren't you play the new game?
Oh no, no. Didn't get a chance to play that because why I yeah the new multiplayer game I just checked it, yeah. No, didn't play it. No. But that's a big hit now, no?
Not the multiplayer game.
Okay. You mean the campaign? No. Did you play it? Is it good?
Not yet, sir.
Okay. Warcraft. World of Warcraft. World of Warcraft. The first time I played World of Warcraft when I was in grade 9. That was in 2001. So Warcraft 1 and 2 was actually very old, and then when in 2001 we got the Warcraft 3, and there was an expansion called Warcraft 4 Frozen Throne. So Frozen Throne was the hit game those days. We used to play it.
Have you played the Forza Horizon game?
Forza Horizon?
Forza Horizon?
Yes, I do play it. I have a Steam Deck. I don't have it right now. May show it to you during the next class. I have a Steam Deck. Have you have seen the deck, right? Yes, I have one of these. I have one of these. This one.
Huh?
The Steam Deck.
Like the Nintendo.
Nintendo Switch?
No, this is not the Switch. This is known as the Steam Deck. So I have a Steam Deck. I didn't buy the Nintendo Switch because this has much more games than Steam, than the Nintendo Switch. So I play all my games here now. I have my PlayStation 4 as well, but I don't have time to play on the PlayStation. So I just take this, and it's portable, no? So you can take it any place, and the battery lasts for about 6 hours. You can play close to about 6 hours with the one full charge. So I do have
The game which very good.
no, it's like this. You have all the games. Literally, you have all the so it's basically a handheld gaming device. So you can I have like 15 games installed. Forza Horizon, Mortal Kombat, all the Batman series and Days Gone and all this stuff. The thing is, you have to buy the games through Steam, though. But it's
Yes, yes.
yeah, but it's
I also have the stream.
you have a
Steam,
Steam.
Steam.
You have a Steam account. Ah, nice, no?
Yes.
Okay.
So
Fine.
I made the Notion.
Ah, nice. Okay. We'll go through it at the end of the class. We can show how we did it to Ethan as well, right?
Okay.
Then he can also
Finish.
follow this up. So yeah, so that we have a proper study plan. Nice. Okay. So so guys, that's about flowcharts. We'll be coming back to this, but so that's the basic idea behind the whole thing, and we will be doing some like extensive flow designs with
Practical.
yes, obviously, yes, with conditional flowcharts as well. Okay, so we are still scratching the surface. Now we jump into, in my personal point of view, pseudocode is the hardest thing which you have in the exam. Okay, when I say hard, it's all about practice. If you practice this and if you learn the flow, then it's going to be very easy. And pseudocode is kind of like a, in my personal view, it's kind of like a ghost which will be with you. If you get into the IT industry, pseudocode will be with you until the end. Okay, because pseudocode now now we wrote this algorithm in a flowchart. No, using a flowchart, we wrote the algorithm down. So pseudocode is how we write the algorithm in a way which will or which can be converted into a program. Okay, so pseudocode will basically allow you to code the solution into an actual programming language. Okay, so can we write this down? Pseudocode. Okay, so I'll tell you the point. So hurry, shall I
Is the P silent?
sorry?
Is
Yes,
the P?
yes, P is silent. You just say it as pseudocode. PSEUDO, but you call it pseudo. Okay, so pseudocode is a structure, code like language that can be used to describe an algorithm. So, this is the part I want you to write. Pseudocode, a structure code like language that can be used to describe an algorithm. You get questions asking what is pseudocode and how pseudocode works.
Sir, it's my flow chart, right?
Ah, yes, please. Uh, can you... Perfect. Nice. Nice, perfect. Okay, be careful when you're like drawing the squares. Make sure that the corners are rounded. Na? So the start and the end should have like broader round corners, and the blocks should also be rounded. Okay, rounded in the sense like හොඳටම round වෙන්න ඕනේ නැහැ, but up to a certain extent that's good. But what you have done is perfect. Nice. So I want you to write this, only this part, pseudocode, a structured code-like language that can be used to describe an algorithm.
Done.
Perfect. Okay. We'll wait until Ethan completes it as well.
Done, sir.
All good. Ah, nice. Perfect. Okay. So, okay. So let's actually check a simple algorithm and see how this can be executed in the system. Okay. So now this is a simple algorithm which you have few points in it. Okay. So in this case, you can see this algorithm. It basically asking for a number. So you first need to enter a number, and then it asks you for a second number. So this is just a number calculation algorithm, right? So it takes the first number, second number, you calculate it by adding the numbers together, then you get a output total. Hari numbers දෙයක් ගන්නවා එකතු කරනවා total එක ගන්නවා, right? So let's look at the pseudocode. So we have the starting point, so we start the pseudocode, and then you get two inputs, no? So you need to get the numbers in. අපි numbers දෙකක් ගන්නවා. So you get the first number, then you get the second number. Hari? Then you try to get the total. So total means the first number plus the second number, and once this process happens, you would be getting the total output. Huh? You get the output, and at the end you end your cycle. Huh? Simple as that. Okay. So this is a simple algorithm written inside a flowchart. Okay. So is the flow clear? Make a flow clear.
Yes, sir.
Okay, nice. Okay, now since you guys can understand this part clearly, now let's see how to write this in pseudocode. Hari? Now in pseudocode, this is going to be a bit of a weird thing. Okay, now here, now we have to first write this as a program, right? So we'll go through this, and I will show you guys how to practice this online as well. Not today itself, but I'll show you guys few websites which you can actually practice this and actually run the pseudocode so that you can see how it works. So pseudocode is basically programming. So here you give the instructions to the computer. In this case, you write the instructions so that a human being can understand, right? Now example is, okay, so if you take this flowchart and if you show it to your, let's say, your grandparents, if they're there, right? They should be able to understand it, right? At least when they read it, they should be able to at least understand what it does, right?
Yes.
But the problem is, now for the computer, you can't expect it to understand it in that way, because remember the peanut butter sandwich example, you have to be precise. Okay, so now in this case, you need to have these precise activities listed like this. So starting off, you have to send a message to the display, right? Because you're expecting the computer to show a message. Okay, so the first line here, you can see here what we do is we send the message to the display, right, asking the user to enter the first number. Okay, so when this first number is entered, now okay, so now you get the message. Now let's say as the user you get the message. Now what you do is you enter a number. Now in this case, you have to receive the number which is being entered from the keyboard, right? So this is the specific way of writing it. So you receive the number, receive the first number from the keyboard. Okay, that's, you have to be specifically mentioning that. Then okay, then what we do? Then first number එක ආවනේ. Now we ask for the second number. Send, please enter the second number to the display. Okay, and then once it's sent to the display, switch the cursor. Yeah, once it's sent to the display, then we basically again listen to this second number and we take it from the keyboard. Okay, now all we need to do is we get the first number and the second number and we set. So let's go through this in depth. I'm just going to take you through the explanation and then I'll explain what this is. So we set, මොකක් හරි එකක් set කරනවා නේ. මොකද දැන් මේ numbers ටික ගත්තට පස්සේ you have to add it up together and you have to save it, no? Save this at a certain point, ne? So you use set variable. So this is known as the variable. I'll go through this. So here you create this thing set and you put it there, and then you send again. You send the total to the display. Simple process, ne? You get the value 1, you set the value 1, you get the value 2, you set the value 2, then you add these values together and set a value as total and you put it into the display. Okay, I hope the flow is clear, right? So that's the same flow which we followed there. Now we have to understand few keywords. Okay, when we make keywords very important because we will be using these keywords now, starting from now until your advanced levels. Okay, now the primary keyword which is very common throughout the internet, like throughout all the software systems, is variable. Okay, so variable is basically just think this as a small container. Okay, so just think have you guys done any CPU level modules? No, right? It's not that cool, no? Okay, so think about this in a different okay, I'll think this as a small container. So what you do is you take two values in and you use this container to put the values into. හිතමු අපි ගන්නවා values 10ක්. So in this case, sorry, values දෙකක්. In this case we take the first number and the second number. And then we put these two values into the variable. And this variable is the container which will basically store the data which we will be using to use later on. Okay, so the values which is stored in is not fixed and they can actually store different values as well. Okay, so and abhi meka practice karanakotta you guys will get used to these terms. So variables and identifiers and operators you guys anyway know. So can you just get these keywords down? So the variable keyword, so this particular
Can I write it?
Yes, can you write this down for them? So variable is a container used to store data. And so just put the title as pseudocode. Put the title as pseudocode, and under the pseudocode title, can you write down these 3 points? So these are all short notes.
we have write the variable contain
Variable, a
the
container
container used to
used to store data. Yes, that is more than enough. So that is more than enough for you to know the basic definition. So that is the definition.
we have write
No, Binlaga, we lost you there. So write the variable a container used to store data, and then identifier a unique name given to a variable or a constant, and please do write the word as arithmetic operator too. So arithmetic operator is an operator that performs calculations on two numbers. Okay. Yeah, we'll go through. Done. Okay. Binlak, are you done as well? Shall I go to the next part? Ethan, are you in a study room? Is it? Is that your study room? Nice. Okay. You have a good whiteboard also, no? That's good. Shall I jump into this? Look, I hope you're okay. Oh, nice. Okay, perfect. So, yes. So, okay, now I'll explain what this is. Now, when this data is being taken in, okay, so what we do is we display something, and then once this is displayed, what we do is we take this data and we take it into a variable. Okay, now here what happens is when this message is displayed on the desktop, when this message is displayed on the desktop, I mean for the user, then this, when the user enters some details, what happens is then it sends you this particular number, right? So the user adds this number in the prompt, and then that number is saved into this variable. So first name is a variable, okay, and then we show the second message, then we take the second message value and we save it in the second variable. Okay, so the second number is going to be the second variable, and then once these two variables are saved, what we do is we run the set function. So the set function is again creating another variable which will basically set as total by getting the by adding these numbers together, right? Adding the first number and the second number together, and then that is going to set into the variable called total, and then that total is going to be displayed. Right? You got the idea? So I can now, so here now what we have is, So when the user enters a number, the number is literally stored in two variables with the identifier, and then the result of the adding the numbers together is again stored in
Excuse
the
me, sir.
variable. Yes, shoot.
Can I log out at 12:30?
Yeah, I'll be finishing at 12:30. Yes.
Okay, sir.
Just few more minutes. So we'll wrap this up at now. Okay. So yes.
We need to insert the commands receive, set, send,
Wow.
those commands like the send, receive.
Send and receive. Yes, correct. Yeah. So these are the commands of what you get with pseudocode. Okay. So we are just introducing pseudocode to you guys right now, but after that we will be writing a lot of pseudocode later on. Na? So here, so we have like questions, we have conditional operators, and so on and so forth. So don't worry, we have a lot of points to cover up in creating algorithms. So now, just for the moment, we'll finish up at this point. So now you can actually read this, and now you get the idea what this does, right? So the pseudocode, how it works. So basically, Ethan and Brennaka, you guys need to learn about, what you guys have to memorize is these specific keywords. So these are the
The
points.
notion?
Sorry?
The notion?
Yes, yeah. So these specific keywords. Okay, so yes, yeah. Show me the notion. What happened? You can share. You can share your screen.
I can't know.
Hold on. Sorry. Yes, I just gave. Yeah, I just gave you permission.
Okay, sir.
Yeah, Ethan, just keep an eye on this one. So I actually showed Binlaka during the last class about a way of creating a study plan. So there's a software called Notion. So by installing Notion.
Sir, can I see?
No, not yet.
Okay, sir.
Yeah, now we can see. Nice. You took the course study plan. Nice. Okay. You created the timetable also. Perfect. Nice. And you added the computer science. Okay. That's awesome. That's awesome. You can.
I also pick my classes.
Nice. Okay.
When I was done, I pick it.
Perfect. That's great. Okay. That's awesome. So, Ethan.
I had some
Yeah.
Call of Duty guns, mythic guns also.
Okay. You can add. Just go down. You have the option of adding notes into this as well, right? Now, if you select.
Yes.
So under the computer science, you have. So if you click on the computer science, you should be able to add. No, not like that. Go down. Task schedule is there. And what about the notes? Don't you
There.
have notes? I know. Not like that text per se. There has to be another thing called notes.
Subject navigation.
Anyway.
No, sir.
Okay. No. Yeah. මේ පැත්තේ තියෙන lesson plans. Go to lesson plans. No, on your left hand side menu. Last. Yeah, go down. No, go down to the lesson plans. Down. That's the one. See, that's the thing. So you can create courses, okay? And based on the courses, you can create lesson plans.
Okay, sir.
So try it out. So there's this thing called, so there you have this EN and so on and so forth. No? So from there you can actually add more items to the group. So
Okay, sir.
so just rename those groups like en-03 and those things, and rename it to whatever the topic which you are going to create the lesson plan on, and then you can add the lesson plan. So click on open one of those plans. Nice. See, you have the plan. You can put objective, you can put the status. So what I suggest is like put the, now example is the one we just did right now. So you can put it as from algorithms and data structures, and you can put the first part as understanding algorithms. Oh, this part, understanding algorithms, right? And then you can actually put down the notes what we discussed, just the flow charts and all this stuff. Okay, so then
Okay, sir.
then that would make it much more easy and straightforward. Yeah, you can call it understanding algorithm.
Yes, sir.
Okay, all right. So Ethan, do you if you can get access to this one, this is known as Notion, Notion. Okay, so Notion allows you to create this type of documents. So here you can actually use Notion to create a document, and Notion has this thing called they have these plans. Okay, so here using these plans you can actually create a structure. So like as the structure which we'll look at just created called the COSI study planner. Okay, so this actually comes out of the box. So all you need to do is just need to fill in the details and structure it according to your plan. So then you can keep everything planned. So try it out and let me know if there's any questions. Super. So guys, shall we wrap it up for today then? We'll catch back on next week. And if you have any questions, please let me know. And
Okay, sir.
next week we'll try to finish up this part, because okay, so just to take it slow, guys, I'm going to go slow with the unit 1 and the unit 2, because these two are the most let's say, I'm not saying hard, but most complex units, where you have the calculations and where we learn about the theories, the architectures and the flowcharts and all. So I'm going to go slow as possible during these things, because I need to explain it more. But once we jump into theory modules, it's going to go fast. Okay, now that's the plan so far, and yeah, thanks. Let's catch back next week.
Okay.
Okay.
Bye, sir.
See you then.
Yeah.
See you. See you. Bye. Bye.